Too much solar wind. A planet too close to its star, or orbiting one with a particularly intense solar wind, could face constant radiation storms and atmospheric stripping, making it hazardous for life. Without a strong magnetosphere, the relentless bombardment of charged particles could gradually erode the atmosphere, much like what happened to Mars. On the other hand, if the atmosphere is thick enough, solar wind could create powerful electrical storms, auroras visible even at the equator, and even hazardous electromagnetic effects that could interfere with technology. Terraforming efforts would likely require massive magnetic field generators, either in orbit at Lagrange points or on the surface, to deflect the worst of the solar radiation, and ideally powered by solar radiation. If the planet still has an atmosphere, shielding infrastructure, such as underground habitats or reflective orbital defenses, could protect settlers from radiation exposure. An alternative approach could be terraforming the entire magnetosphere, using vast superconducting loops at the poles to generate a protective field. Now, we've mentioned magnetic deflectors a lot in this episode, but using the context of a planet around a single star and with stable Lagrange points with that star. And that won't work on moons or planets around binary stars or other cases too, without modification. It's handy that a magnet doesn't have to be a bulky thing and that a power collector is probably very thin, and this allows us the option of employing a lagite, a mix of a solar sail and a satellite, or thin megastructure to allow a non-Keplerian orbit, or basically something that can hang out in between two bodies in space where your normal orbits wouldn't allow, and without huge amounts of thrust and fuel being required. Indeed, they could be deflecting solar wind or gathering it to harvest and use, and in part as a fuel for an ion drive for station keeping. Key notion though is that they allow placement of mirrors, shades, deflectors, and shields at places we wouldn't expect, and to keep themselves there, thus can be used to deflect particle radiation from some distant binary partner, or even from some radiation source like a galactic center, an active galactic nucleus or quasar. This isn't limited to solar wind either. This could be a big thin inflated shield designed for stopping ionizing radiation, or enemy weapons. We also need to be mindful that many stars give off far more solar wind than our Sun, and often in catastrophic bursts that make a solar flare, or even a coronal mass ejection, seem like a hiccup.